An independent editorial analysis of Japan's defense posture and security policy.
The divergent trajectories of the Japanese Type 19 wheeled self-propelled howitzer and the South Korean K-9 Thunder tracked howitzer provide a compelling case study. They illustrate exactly how national defense doctrine and procurement strategies shape industrial viability. On paper, both systems utilize the NATO-standard 155 mm caliber with a length of 52 calibers. Theoretically, they offer similar ballistic performance. Yet, their operational footprints and market destinies could not be more distinct. This divergence is not merely a reflection of engineering capability. Rather, it stems from a fundamental difference in how Tokyo and Seoul conceptualize the relationship between domestic operational requirements and the global defense market. From an operational standpoint, the design of the Type 19 reflects a rigid adherence to the specific geography and infrastructure of the Japanese archipelago. The decision to mount the artillery system on a wheeled 8x8 MAN tactical truck chassis is driven by necessity. Specifically, the need for high strategic mobility across the dense Japanese highway network. The ground self-defense force prioritizes the ability to rapidly redeploy firepower from one region to another to counter potential island invasions. In this scenario, speed on paved roads outweighs cross-country performance. Consequently, the platform sacrifices armored protection for the crew and off-road traction. This is a calculated trade-off to achieve a lighter weight profile, suitable for air transport via the Kawasaki C2. This suggests that the Type 19 is a specialized tool. It is optimized for a singular theater of operations, functioning effectively within the constraints of an exclusively defensive posture. In contrast, the design philosophy underpinning the K-9 Thunder addresses the requirements of high-intensity continental land warfare. Originally, this was necessitated by the threat landscape on the Korean peninsula. The utilization of a tracked chassis, combined with significant armor protection for the crew and ammunition, indicates a different set of priorities. It prioritizes survivability under counter-battery fire and mobility across rough, muddy, or frozen terrain. This configuration aligns closely with the renewed demand for conventional attrition warfare capabilities, as seen in Eastern Europe. The global market success of the K-9, with massive contracts in Poland, Norway, and elsewhere, validates a key reality. It confirms that the international baseline for self-propelled artillery remains rooted in survivability and rough terrain mobility. These are features that the Type 19 deliberately eschewed to meet domestic logistical constraints. This doctrinal bifurcation creates a severe challenge for the sustainability of the Japanese defense industrial base. The procurement strategy for the Type 19 has followed a low-rate initial production model. Acquisition numbers often hover between 7 and 12 units annually. Such low volume prevents the manufacturer from achieving economies of scale. The result is a significantly higher per-unit cost, estimated at roughly $7 million. This is nearly double the export price often cited for the K-9. This introduces a negative feedback loop. High costs limit procurement quantities, which in turn keeps costs high and renders the platform uncompetitive globally. The Japanese system effectively becomes a boutique product, technically proficient, but economically inefficient. Furthermore, the industrial approach demonstrates a critical difference in supply chain integration. The Type 19 relies on an imported German chassis rather than a domestic platform from Mitsubishi or Isuzu. This highlights a potential gap in the coordination between indigenous automotive capabilities and defense requirements. This reliance on foreign subsystems for the mobility component of a sovereign strategic asset introduces a layer of supply chain complexity. A complexity that does not exist for the K9. The Korean model utilizes a vertically integrated domestic supply chain, including the engine and transmission in its latest variants. This allows for rapid production scaling. Evidence of this is the ability to deliver initial batches to Poland within months of contract signature, a feat that the current Japanese production infrastructure would likely struggle to replicate. The disparity in export performance also illuminates the role of government support in defense sales. The success of the K9 is not solely due to hardware specifications. It is bolstered by a comprehensive state-backed export strategy, one that includes technology transfer, local production licensing, and flexible financing. This total package approach treats defense exports as a diplomatic and economic engine. Conversely, Japan's defense industry has historically operated under strict, self-imposed restrictions. Even with recent policy relaxations, the sector lacks the institutional experience in structuring complex government-to-government deals that involve industrial offsets. The Type 19, therefore, competes as a standalone piece of hardware, rather than as part of a strategic partnership. There is also a significant strategic trade-off regarding the future-proofing of these platforms. The tracked chassis of the K9 offers a substantial weight margin for future upgrades. This includes potential autoloader systems and unmanned turret integration. The wheeled chassis of the Type 19, however, is limited by axle load restrictions critical for road legality in Japan. It possesses a narrower margin for weight growth. This constraint implies that as artillery technology evolves toward higher automation and heavier ordnance, the Type 19 may face obsolescence sooner, or it may require a completely new platform design to accommodate next-generation capabilities. Ultimately, the situation presents a systemic dilemma for Japan's defense planners. The Type 19 is arguably the correct tactical solution for the ground self-defense forces' specific doctrine of rapid island defense. Yet, it is a strategic liability for the defense industry due to its lack of export viability. It highlights a tension between optimizing equipment for unique national geography and designing platforms with enough commonality to appeal to the global market. As defense budgets tighten and development costs rise, the inability to subsidize domestic procurement through foreign sales places an increasing burden on the Japanese taxpayer, and it risks the atrophy of specialized engineering skills. The case of the Type 19 and K9 Thunder serves as a stark indicator. It shows that technical excellence alone does not guarantee strategic success. It underscores the necessity for a defense industrial strategy that harmonizes operational requirements with industrial sustainability. For Japan, the continued isolation of its equipment specifications creates a risk of a Galapagos effect, where its defense technologies become highly evolved for a specific local environment, but struggle to survive in the broader competitive ecosystem. The future capability of the ground self-defense force may depend not just on the performance of its cannons, but on whether its industrial base can transition from a model of artisanal domestic production to one of globally integrated manufacturing.